Hey everybody, welcome to Helvetic Arms. In this segment, we're going to go over the mechanical operation of the vz.58. This is going to be done by our guest, Dale, the STGW dude. He has a great channel on YouTube and a lot of information about the STGW57, and he's also knowledgeable about many other platforms as well. So thanks to him for doing this breakdown for us. And we also have a longer full video on the tabletop breakdown of the vz.58. And if you're interested in that, please go check it out on our channel. And if you are just interested in the mechanical operation, then this is that portion for you. So thank you, and please enjoy.
All right, so to describe how the vz.58 works, it's interesting to take a look at the cutaway because the Czechoslovak cutaways are really elaborate, and you can see they really removed as much material, as little material as possible to show you how much of the things work. You know, for example, even the detents on the piston cover, the cutaway here for the captive takedown pin, etc. So it's a very detailed cutaway, very awesome to explain. Now, to understand how the rifle works, fundamentally, if we take it down to basics, this is a gas operated with a short stroke piston, with a tilting block, locking mechanism, linear hammer, box magazine fed with kind of an open bolt style of trigger mechanism, which is pretty interesting. So it doesn't have a swinging hammer as we mentioned before. Now, to kind of describe to you how it works and to show you how it interacts in the cutaway, we can go through the cycle of operation. So the first step would be feeding, in that case. Magazine is of a traditional double stack, double feed configuration. And you can see when the user rocks in the magazine, the tab is actually offset on the vz.51, which is a bit unique. The support is only one-sided, and it engages and locks the magazine in place. Now, when the user retracts the bolt, the magazine spring pushes the topmost round in the path of the bolt.
These are dummies, by the way, in case you're wondering.
These are dummies.
these rounds are dummies.
And also, luckily, the firing pin is blocked on this one. So I hope nothing's going to happen. And once the round is seated inside the chamber, notice that when the bolt is driven home, the locking block drops into the locking surfaces inside the receiver. And that's how the gun is in battery. So if the bolt thrust were to be applied this way, it is resisted on this critical locking surface on the other side as well. Now, there is a bit of lifting force, which is countered by the bolt carrier itself. So there's also a hook here. It's a bit like a tilting bolt, except that the bolt itself is stationary and the tilting is done by an independent piece, so to speak.
Can we just show the audience real quick a little bit just in there? Look at how, if you can see that, that's a really nicely done example where you can really see everything that's going on there. So some of the parts there, very good.
So let me show you in terms of the trigger mechanism how this thing works. Now, you can see that this thing essentially basically works like a full auto machine gun, in the sense that you have a sear that interacts with a linear hammer sear notch here. And in the safe mode with the safety wing pointing down, what it does is that it cams the disconnector down. So it removes any sort of interaction of the trigger blade to the sear. Now, there is a slight weakness in the design. If you were to depress the sear manually, suppose a shock or some sort of foreign load, the striker can't drop. Sorry, the linear hammer can't drop. So there is no positive locking of the sear, only a passive disconnect with the trigger blade. So once I flip, let's say on semi-automatic, you can see through the little cutout on the disconnector itself, I'm actually now engaging the sear. You can see it moving, camming back the linear hammer. Now, there's no break point on the trigger. It's basically just a smooth, constant pull. And when that happens, under the pressure of the hammer spring, which is fixed onto the receiver cover as mentioned by Helvetic Arms, that linear hammer is driven forward into the base of the firing pin, which is nested inside the bolt. You can probably barely see it peeking through the bottom of the channel there. And that ignites the round, which pushes the bullet down the bore and creates a gas stream. Now, as mentioned before, this is a locked bolt design, so the bolt stays stationary and resists the opening thrust, so to speak, exerted on by the case. And when the bullet goes past the gas port, which is shown right here, affixed to the gas block, gas starts streaming into the expansion chamber on the piston, and that starts creating work, basically movement of the piston in this direction. Now the bullet will keep going on until the piston has generated enough work to start moving the carrier itself. Now to show you how much the mechanism moves, I can remove the shroud and you can see this is the useful amount of work that the piston is expected to do. Now there is an exhaust port which is also cut out right here. And you can see that once the edge of the piston clears that exhaust port, all of the energy has been communicated to the bolt carrier. Now it's a very good design in my opinion because the total amount of piston travel also corresponds to unlocking as well. So there's a lot of energy that's being used to push that bolt open, because part of the difficulties of making a gas-operated mechanism like this with kind of rigid extraction is that you need to overcome all the friction inside the system. So the friction of the case in the chamber, the friction of unlocking, and in the case of rotating mechanism, the actual friction of the extractor rubbing against the case rim. So having a lot of energy, a lot of useful momentum in the system to work the bolt is very important. And in this case, in the vz.58, it's very well done because the amount of allowable travel in the piston actually translates into the breaking free of the locking block. So given that this impulse is nice and sharp, it's going to drive the rear of the carrier forward, or actually to the rear, excuse me. And the extractor, which is rigidly mounted onto the bolt here, is going to yank the empty case out. It's going to hit the ejector, which is this fixed post inside of the receiver. And at the same time, the next round pops up, ready for chambering. Now, as I do this simultaneously, I've also moved the hammer back. I cocked the hammer against the spring. And here's a clever part of the design, is that when the carrier moves rearward, it actually has to overcome two springs, the hammer spring and the recoil spring. So it kind of adds a buffering effect, and to avoid too much wear and tear on the relatively frail section of the receiver there, because the cross sections, being the weapon had to be very light, are not terribly large.
To add to that, one of the main concerns in the Soviet report evaluating the weapon was that there was a lot of impact onto the rear of the receiver that managed to unscrew the folding stock at times, which isn't a technical hindrance, but it is a usable hindrance. So that's something that was, I guess, problematic enough for them to mention it in the report itself.
Yeah, definitely. I think what the solution to that is to actually stake or to deform the screw there. So it's actually very difficult to remove on a factory new weapon. I guess that's how they dealt with the vibration problems. Yeah, but you can understand that it's to the audience can understand that it's to the designer's interest to reduce as much as the impact as possible. And the usage of the two springs, in my opinion, is probably one of the design intents of having this inline hammer design. Also, because it saves a lot of space in the assembly, so the entire receiver can be made more compact, and that lightens the weight.
Can we just pull up just the thickness of an AK receiver, just to compare real quick, as a mini side note here, to just examine just how compact this gun really is. Mm-hmm. We can see the AK receiver is at least a few centimeters longer than the VZ. The receiver is also thicker, and the AK is not known to be a large weapon either in any sorts of way. So we can see that the VZ is yet thinner, yet more compact than the AK in many respects. So
it's quite impressive. And also the fact that they integrated the sight base to the receiver means that you don't have to dedicate as much weight for the entire assembly. They try to integrate as much as possible to make sure you don't have too much material. I think that's what makes this design particularly clever. But going back to the linear hammer, the reciprocation of the carrier meant that I could now actually rest this on the sear notch. Now the disconnecting is interesting. If you take a look at on this side, now imagine this during the cycle of operation, the bullet is traveling down the board, the piston is acting. You can see that the auto sear or the safety is depressed. What happens is when the carrier reciprocates, you can see there's a second sear behind the primary one that pops up, ready to receive the linear hammer. And it's clever because I don't know if you can see it on the camera's perspective, but the second sear is ever so slightly offset the primary one. So it'll always catch first if it's up. Let me show you. So you can see now there's a distinct gap between the primary sear. It's actually resting on the secondary one. And once the safety lever is depressed, thus depressing the secondary sear, it's going to close the gap and touch the primary sear. That's how the out of battery safety works, or the automatic sear as well. Now for the disconnector function, you can see the disconnector has a tang right here. When I depress the disconnector, the primary sear pops back up. And to reestablish the trigger reset, it climbs back up onto the sear and I could depress it again. Now what's very clever about the design is that there's a kind of a redundancy in the system. When the bolt carrier passes, you can see the tang right here already depresses the disconnector once, like this. But if you were, for some unnatural reason, to release and press again, you can see the second passage of the carrier depresses it again to make sure that that linear hammer stays back. So it's a very clever and well thought out design.
Wow.
Now, how do I distinguish fully automatic and semi-automatic fire? In this case, I'm in semi-automatic fire. What this does is that it allows the disconnector to be up even when the carrier is moving. So this means that the disconnect is forced. However, when I move this to the fully automatic position, you can see it cams the disconnector down. And so here, only the out of battery safety or automatic sear controls the position of the linear hammer in relationship to the bolt carrier. And putting it back on safe, as shown earlier, disconnects the trigger altogether with the sear mechanism. So very, very clever design. I think that pretty much covers the overall function of the vz.58. I think the last thing to show would be the bolt hold open when the last shot is fired. And so here on the cutaway, it's clearly shown. In fact, the bolt hold open on the vz.58 is almost scarily frail in the sense the only thing that holds the entire bolt back is this little nipple that's sticking out right there. That's holding back the entire brunt of that carrier there.
Let's see that nipple again, guys. Let's see. We have right here. Can you see it? I don't know if you guys can see it on the camera. There you go. So just so our audience can see that nicely, that is a small bit of material indeed.
Yeah, definitely. So the engagement surface is absolutely tiny. You can see this little pin basically just sticking out in front of the bolt, and that's what holds it back. Now, to actually actuate this automatically, as shown by Helvetic Arms, the follower has a projection or kind of a window through the mag here. In fact, the entire mag had to be cut out for this particular projection. And at the last round, you can see it already kind of pre-engages there when I insert the magazine. It presses directly onto the base of that pin against its spring. And when the bolt carrier returns on the last shot, that's how the bolt hold open is actuated. Now, the only thing that holds this back is friction, which in my opinion is a bit of a design flaw. The reason for that is that any small disturbance in the bolt carrier will kind of delete your hold open. So if you were to fumble around with a stripper clip, it might close on your thumb. Other designs have more positive hooks, which means you actually have to pull back the bolt a certain amount for the bolt hold open to drop down. Unfortunately, this isn't the case here. It's just friction. So you can technically just jar this and you can close.
Mm.
So honestly, that about covers it. I mean, it's a very well thought out compact system. Of course, they had to sacrifice rigidity and strength in exchange for weight, but I think it's a good compromise overall. What I also find very clever about the design is the gas system, which is extremely compact. In fact, this isn't really even a tube, it's just a cover. It's just a cover to prevent the piston from popping out of its normal position. Everything actually happens in the gas block. It's a very tight, compact design. And overall, I think this deserves to be manufactured in such high numbers and to be such a successful weapon overall. Yeah.
All right, so that concludes our mechanical operations segment of the VZ58. Big thanks to Dale again for going through that for us. If you are interested in the full-length VZ58 tabletop overview video, I will link that in the end screen, and be sure to check out Dale's channel in the description. Really appreciate it. Thanks for watching.